These are your 2-1 notes on writing equations. Today, our key objectives are to take a verbal sentence and put it into a symbolic algebraic equation, and then also take those symbols in that equation and translate it back into words in a sentence form. So before we do that, we did this in chapter 1 with expressions, but an expression doesn't equal anything, so it's just a statement. It's adding, subtracting, multiplying, dividing numbers and variables. So now we're going to take that same concept, build upon it, and now we have equations. So equations have an equal sign. So some words that are the same thing as equals in the English language are several of these. So if you know I have the key on your notes, if you just want to put this list down below it. So is, and then if you have is, that's your present tense form of the word. Was is just the past tense of is, and will be is the future tense. So each one of those forms is still saying is, equals, equal to, identical to, as much as, or the same as. We also use totals. It totals, and that just means that it's the equals of a summation when you're adding. So make sure you copy down all those words so that when we translate these words to equations, we know where the equal sign lies. So we're just going to go ahead and get started here. And I like to take the words and then just put the symbols above them. So I'm identifying some key elements from before. A number. So for instance, a number, and they actually give me the variable b, divided by 3 is 6 less than c. Well, actually, we needed everything there. So a number, b, is the first thing I'm going to take care of. Divided by, I'm going to put it as a fraction, 3 is, which is our equals. Now I see 6 less than c. I always like to put it afterward. This less than, you have to ask yourself when you're subtracting, what did I have to begin with and what am I taking away? If I'm taking 6 less than c, I had c amount of something and I'm subtracting 6 from it. So watch that than part of less than. Part B, 15 more than. 15 more than is addition. Here's my z, times 6, here's my equals. 11, here's that less than again, y times 2. So 15 more than z times 6. 15 more than 6z. Try to get in the habit of when we multiply variables and numbers that you put the number out in front of the variable. Technically speaking, this has that than as well. So technically speaking, we should have these two flip-flopped. We should have 6z plus 15. But because of the commutative property that we learned about last chapter, order really doesn't matter for addition. So this is okay as well. Equals 11 less than y times 2. So 2y minus 11. The 11 definitely has to be after the 2y. Part C here, the sum. Okay, so the sum is telling you what we're adding of 8 and 3 times k. Oops, I didn't circle all of that. Is the same as is my equals. The difference of 5 times k and 3. 5 times k and 3. So the difference, we're going to subtract the two things, and the two things we're subtracting are differentiated with this and, so that tells me what we're subtracting. 5 times k and 3. So the sum of 8 and 3 times k, that's 8 and 3 times k, is the same as the difference of 5 times k and 3. So when we use words like sums and differences, we have to have the and that differentiates what we're adding or what we're subtracting. So that's just taking the actual words and putting them into symbols. Now let's just take some time to do the reverse. So now we're going to take some time to put each of these equations into words. So I'm actually going to type these up. And I'll just put them in a different color here real quick. So I'm going to say we got 12 and we've got a minus 2x. So I might just do just that. 12 minus 2 times a number is equal to negative 5. It can be very simple. Don't get too fancy. Sometimes when you try to get too fancy, you tend to say something that you didn't mean. Now we're adding and multiplying, so I might say the addition might be the sum. Let me turn that to red real quick. There's my red. The sum of, now since I mentioned the addition, a number squared and 3 times another number is the same as C divided by 6. I suppose since we had 3 different variables there, I could have just said A, B, and C. I know the book does that. Try to stick to a number for variables, but if you can't, if you have to name the actual variable, that's fine too. So let me get that to fit there. And now we've got a quantity, so this is a sum. So I'm 3 times the sum of is what I might say there. So again, I'm just going to type, make sure it's red, so you can see the difference here. And there's more than one right answer here. So 3 times the sum of G and 8 is equal to 4 times H minus 10, or 10 less than, or 10 subtracted from is what we could say there. So I think you get the idea. There's more than one possible solution there. Now we're going to get into some actual words that the variables mean something. So F is the cost of fries. That's what's nice about a variable. You can make it equal different values, and by putting the F, you can think fries. And then F plus $1.50 is the cost of a burger. A burger costs $1.50 more than fries. We don't know how much our fries cost. We could write an equation based on the fact that we know our total cost. We're not going to solve this equation. We're just going to write a problem based on it. So this right here is the cost of my burger, and I'm multiplying that by 4. So maybe some scenario about 4 burgers and then 2 fries. And then this is my total amount because that's what it equals. So I might type up a problem very similar to that. So looking at what each of those variables mean and what they represent, I can go ahead and type up the problem. Maybe I ordered 4 burgers and 2 fries, and my bill was my bill totaled $8.25. That's the problem. Maybe you could say, how much do the fries cost? You might ask how much the burger costs. It all is based on the fries price. So that's one example of just using the equation, making sense of it in real life. Another one here, we've got D is equal to dinner, and then 20 cents times D is the tip, or not 20 cents, but 20% if you wanted to say. So D represents dinner, and then plus the tip. So that would be my total bill there, if that's what you're looking at. So we could say dinner and tip equaled $29.75. And actually, if I wanted to say, I could even be a little bit more specific about my tip. Dinner and a 20% tip equaled $29.75. How much was my dinner? More than one choice there. So for your lesson summary, I'd like you to just translate each of these. One's a sentence with the words, change it to symbols, and then change the symbols into words.